The sun, a blazing ball of plasma that dominates our sky, it is the ultimate source of energy for our planet, driving our weather, shaping our seasons, and sustaining all life as we know it. Without the sun, Earth would be a lifeless, frozen wasteland. For millennia, humans have gazed upon the sun with awe and wonder. Ancient civilizations worshipped it as a deity, recognizing its power and importance. Today we understand the sun in greater scientific detail than ever before. Yet it remains an object of immense fascination, its mysteries continuing to captivate scientists and stargazers alike. Join us on a journey to uncover the secrets of our nearest star. We will delve into its fiery heart, explore its explosive outbursts, and discover how its energy can be harnessed to power our world. This is the story of the sun, our very own star. The sun is a massive ball of hot ionized gas called plasma. It is composed mainly of hydrogen and helium, the two lightest elements in the universe. These elements are constantly engaged in a furious dance of nuclear fusion, the process that powers the sun. The sun's structure can be divided into several layers, each with its unique characteristics. At the sun's core, temperatures and pressures are extreme. Here, hydrogen atoms are fused together to form helium, releasing an enormous amount of energy in the process. This energy then slowly radiates outwards through the sun's radiative zone. Moving outwards, we encounter the convective zone. In this turbulent region, hot plasma rises to the surface, cools, and then sinks back down, much like boiling water in a pot. This convection process transports the sun's energy from its interior to its surface. Finally, we reach the sun's atmosphere, which consists of three main layers: the photosphere, the chromosphere, and the corona. The photosphere is the visible surface of the sun, the layer that emits the sunlight we see. The chromosphere is a thin layer of gas above the photosphere, visible during solar eclipses. And the corona is the outermost layer of the sun's atmosphere, extending millions of kilometers into space. The sun is not a static object. It is a dynamic and ever-changing star, prone to sudden outbursts of energy. These outbursts, known as solar flares and coronal mass ejections, or CMEs, can have significant effects on Earth. Solar flares are intense bursts of radiation from the sun's surface. They are caused by the sudden release of magnetic energy stored in the sun's atmosphere. CMEs, on the other hand, are massive eruptions of plasma and magnetic field from the sun's corona. They are often associated with solar flares, but can also occur independently. When directed towards Earth, solar flares and CMEs can interact with our planet's magnetic field, causing a variety of effects. These include auroras, disruptions to radio communications, and even power grid failures. While most solar storms are harmless, large events can pose a significant threat to our technology-dependent society. The sun is a virtually inexhaustible source of energy. Every second it releases more energy than humanity has consumed in its entire history. Harnessing even a small fraction of this energy could provide a clean and sustainable solution to our energy needs. Solar energy can be harnessed in several ways. Solar panels, also known as photovoltaic cells, convert sunlight directly into electricity. Solar thermal systems use sunlight to heat water or air for residential and industrial purposes. And concentrated solar power plants use mirrors to focus sunlight onto a receiver, generating heat that can be used to produce electricity. Solar energy offers numerous benefits. It is a clean and renewable energy source that does not produce greenhouse gases or other pollutants. It reduces our reliance on fossil fuels, contributing to a more sustainable energy future. And it can provide energy independence, reducing our vulnerability to fluctuations in global energy markets. Section 5. Myths and misconceptions. Separating fact from fiction. Despite our growing understanding of the sun, many myths and misconceptions about our star persist. Let's debunk some of the most common ones. The sun is yellow. The sun emits light across the entire visible spectrum. It appears yellow to our eyes because Earth's atmosphere scatters shorter wavelengths of light, such as blue and violet, more effectively than longer wavelengths such as yellow and red. The sun is a giant ball of fire. The sun does not burn in the traditional sense. Its energy is produced by nuclear fusion, not chemical combustion. The intense heat and light we see are the result of this nuclear reaction. You can get a sunburn on a cloudy day. While clouds can block some of the sun's ultraviolet or UV radiation, they do not block all of it. It is still possible to get a sunburn on a cloudy day, especially if the clouds are thin or broken. Section 6. A star's journey, the sun's life cycle. Like all stars, the sun has a finite lifespan. It was born from a collapsing cloud of gas and dust about 4.6 billion years ago and is currently in its main sequence phase, where it will spend the majority of its life. During its main sequence phase, the sun fuses hydrogen into helium in its core, releasing a tremendous amount of energy. This process creates outward pressure that balances the inward pull of gravity, keeping the sun in equilibrium. However, the sun's hydrogen fuel is not infinite. As it continues to fuse hydrogen into helium, the composition of its core gradually changes. Eventually, in about 5 billion years, the sun will exhaust the hydrogen in its core and begin to evolve off the main sequence. Section 7. Our sun's fate. A glimpse into the future. As the sun exhausts its hydrogen fuel, it will enter a new phase of its life cycle. It will expand dramatically in size, becoming a red giant star. During this phase, the sun will engulf the orbits of Mercury and Venus, and Earth will become uninhabitable. Eventually, the sun's outer layers will drift off into space, forming a planetary nebula. This expanding shell of gas and dust will carry with it the building blocks of future stars and planets. At the center of the planetary nebula, the sun's core will remain as a small, dense object called a white dwarf. This stellar remnant will slowly cool and fade over billions of years, eventually becoming a black dwarf. Section 8. The sun's impact, Earth's lifeline. The sun's influence on Earth extends far beyond providing us with light and warmth. It is the driving force behind our planet's climate, weather, and seasons. The sun's energy drives the water cycle, evaporating water from oceans and lakes, which then falls as precipitation, replenishing rivers and groundwater. The sun's energy also drives photosynthesis, the process by which plants convert sunlight into chemical energy. This process is the foundation of most food chains on Earth, making the sun the ultimate source of energy for almost all life on our planet. Furthermore, the sun's magnetic field helps to shield us from harmful cosmic rays and solar wind. Without this protection, life on Earth as we know it would not be possible. Section 9. Respecting and protecting our star. The sun is a powerful and awe-inspiring object essential for life on Earth. Understanding its workings and appreciating its significance is crucial for our continued existence on this planet. While the sun will continue to shine for billions of years to come, its future evolution will have profound implications for Earth. As we continue to explore and learn more about our star, we must also strive to protect our planet from its potential hazards, such as solar storms and the long-term effects of its evolution. By embracing sustainable practices, reducing our reliance on fossil fuels, and developing technologies to mitigate the risks posed by solar activity, we can ensure that future generations continue to benefit from the sun's life-giving energy. Let us respect and protect our star, for it is the ultimate source of our planet's vitality and our very existence.